Hey, so I have this system of logarithm equations on the board, and I thought it was kind of interesting because you don't usually see a system with logarithms. So what I'm going to do, we'll label these equations. We'll have 1, 2, and 3. And so we'll start with 1 and we'll just use logarithm rules to simplify this. So first what I'll do is, we notice we're multiplying something in the log, so we can break this apart and write this as log 12 of x plus log y to the 4th equals 37. And then again, what we can do is we can just move this 4 again by logarithm rules to the front. So we'll have log 12x plus 4 log of y equals 37. And this will be our equation 1. Then next we'll go to equation 2, and we're going to do really the same kind of, so we'll subtract, we can write this piece as log 12 y to the 4th minus log x equals 19. But then I just want to manipulate this and have the x term in front. So we'll rewrite this as log 12 to the x, and minus log 12 to the x, plus log 12 y to the 4th equals 19. And then again, I should have done this in one step. We can move the 4 to the front, and this will be our equation 2. And then all we want to do, what's really going on here is this looks like a log problem, but it's really just an algebra problem, a system of equations. So what I can do is I'm going to do a substitution. I'm going to call log 12x we'll call a, and log 12y we'll call b. And then so if we rewrite this in terms of a and b, we end up with, we'll go back to our equation 1, we'll end up with a plus 4b equals 37, and we'll have here minus a plus, we end up with a 4, again, a 4b equals 19. And so all we need to do is solve this equation, but I'm out of room, so I'm going to do is erase the board and we'll bring that to the top. Okay, so now that we have this at the top, what I can do is I can just add these two equations because it's going to cancel out the a, and we'll end up with 8b equals 56. So dividing an 8 on both sides, we end up with b equals 7. And then what we can do is, let's plug this back in. Let's plug it in to this first equation. So we'll have a plus 28, 4 times 7 is 28, equals 37. So then a is going to be, 9. So we got a is 9 and b is 7. Now that's good, but we don't, back to the problem, we want to solve equation 3, and we don't have an a and b. But what we can do is we can rewrite equation 3 the same way we did equations 1 and 2. So we'll write this as log 12 y to the 5th minus log 12 x squared. And again, we can bring our exponents to the front by log rules, and we can say 5 log 12y minus 2 log 12x. But then this is just b, and this is just a, so we end up with 5b minus 2a. But then we already found those values. So what I'm going to do is I'm just going to substitute those back in. So we'll have 5 times 7 is 35, minus 2 times 9. We end up with 35 minus 18, and our answer is 17. And that's the answer. So we got the answer, but notice that we never actually used the base. We never actually had to calculate a log because it's really just log rules and then a basic algebra elimination problem.